of shown you guys this throughout. What happens when we're looking at graphs of sines and cosines, basically what we do, well, really, in essence, what we do is, all we're worried about is the values of the sines and cosines and sines on the quadrantals. Remember, your cosine and sine values when you're on the quadrantals are your ordered pairs, your zeros and ones. So at 0, cosine is 1, sine is 0. Pi over 2, it is 0 and 1. At pi, we're at -1 and 0. At 3 pi over 2, we're back to 0 and -1. And then when we come back up to 2 pi, we've gone full circle. Sorry, that wasn't meant to be funny, but it kind of worked. So what happens is, as you go around the circle, it takes you 2 pi to get all the way around. And after you go around once, it just repeats itself. If something repeats itself along the same cycle, it's called a periodic cycle. It's the same thing happening over and over and over again. All right? Over this. So what happens if you take these things and you look at them in terms of the sines and cosines, what I like to do, I like to start with a sine graph, because I think, for some reason in my mind, working with a sine graph, it seems very simplistic. So here's what I do. I'm going to look at the function y equals sine of x, and I'm going to plot it via my quadrantals. If I look at where my values of the 4 quadrantals are, it starts at 0, pi over 2, pi, 3 pi over 2, and it goes back to 2 pi. Everybody okay with that? So if I start at 0, and I come all the way out here and I end at 2 pi. What's halfway between 0 and 2 pi? Pi. How are you? What's halfway between 0 and pi? Pi over 2. And over here it is 3 pi over 2. Now I'm going to show you guys a nice little shortcut. By placing my period, my breakpoints on that horizontal axis like that, notice I started at the beginning and the end, cut it in half, and I cut it in half again. And now, what's going to happen as we get into weird values of a period, what I want you just to see is 1 half, 2 halves, 3 halves, 4 halves. So we could wind up with a period that might be pi over 8. Half of pi over 8 is pi over 16. Half of pi over 16 is pi over 32. 1 32nd, 2 32nd, 3 32nd, 4 32nd. It's a very easy way to calculate with fractions, just by cutting things in half. Trust me. Trust me. I haven't led you down the straight path yet, okay? Kind of, but not all the way. All right? Now, when you think about your values of sine and cosine, what is the maximum value of a sine value? What's as high up as it goes? What's the highest value of y? 1. What's the lowest value of y? -1. So when we're talking about heights, we talk about what's called amplitude, how high up and how low something goes. And amplitude is just the measured distance of a height of a curve from 0. In this case, our amplitude is 1. Okay. So at 0, sine is 0. At pi over 2, it jumps up to 1. Pi, it's back to 0. -1. And back to 0. So what the sine curve does as it goes through a unit circle of oscillation, it's actually doing this if you stretch it out. As we switch that into that, instead of a circular graph, we stretch it to an XY grid, the sine graph turns into a curve. Okay? I want you guys to see that your sine graph, since you start at 0, your sine value at 0 is always 0. It then goes to its maximum, 1. It goes back to 0. It goes to its minimum, and it goes back to 0. This curve is duplicated over and over and over again as it gets to what we call its parent function. The parent function of this looks like this. Y equals A sine bx. Obviously, we're going to add more into that stuff tomorrow about the whole shifting, because when you shift things, you're moving things horizontally and vertically. So tomorrow we'll add an h and a k to it, but for today, we have a's and b's.
Wait, where does the A and B come from?
I'll show you. These a's and b's come into play with the a is a scalar. It's a multiplier to raise or lower the curve for its height. The b value works with how fast it oscillates. It works with its period. Okay? So you get something that looks like this. We rewrite that. Y equals a sine bx. This value of a, oops, that's a very bad arrow, does one of two things. First thing it does, it tells direction.
Like negative or positive?
Yep. Tells direction. Whether you're going to go up first or down first. It all works out here in a second. It's very, very simple after we write out some rules. The second thing it does is that if you take the absolute value of A, gives what's called, oops, can't be right, what's called amplitude. And the amplitude just means how high up the peaks and valleys go. Where does the maximum go up to? Where does the minimum go to? Then, like you were asking, Sarah, it's kind of like the scalar.
Okay.
Think about slope. Slope is the mx.
So it's like how many up and down, up and over?
Yeah, exactly. And like the positive slopes is up to the right, negative slopes is down to the right. A positive A means I go up first. A negative A means I go down first.
So it's kind of a slope.
Yeah. A values, if you always, with every curve that you've seen so far, or every graph, that A value always played the role of slope. Absolute value graphs, A value was the slopes of the two parts. Sine graphs, it's the same thing. It's going to tell you directions. What's the other one we did with A's and B's? No, those were foci and stuff. What was it? Quadratics. Your A value, your ax squared. Told you it was up, like, up, down, and frown. What's that? We do have more dance moves. Tangents. It's all, we got all the cool stuff. No, I can't. Not at all. Your B value here is going to help define the period. The period of sines and cosine graphs are always going to be this. The period is going to equal 2 pi over the absolute value of b. I wouldn't worry so much about that absolute value of b. I honestly don't think your textbook ever uses a negative b value. I really don't. I honestly don't remember seeing that because we don't do much with negative angles in algebra 2. Yeah?
What's the period of
We'll get there. It's completely different. Because if you think about it, tangent has asymptotes. Because tangent doesn't occur at pi over 2 and 3 pi over 2. So all of tangent occurs between those two, and then you get asymptotes. Shh, don't tell anybody. I don't know, I forgot. Now, these rules, huh? What? These rules also follow the same thing for the cosine. These rules also occur the exact same way for cosine. The only difference is where cosine starts versus sine. Right? Cosine, if you think about it, let me graph them both here. Let me graph them both on the same line. We have all this. This is basically everything you need to know to graph these two things. We have this okay?
Sure.
All right, let me show you where I'm getting at with the difference between sine and cosine. if I look at sine graph, just a regular sine graph and a cosine graph. If I start with sine, oops. And we're going to do one ringy dingy of the circle. Your sine graphs always, we just graphed this. Your sine graph started where? It started at 0. Your sine graphs, and this is going to be a general rule here, your sine graph starts at 0, always moves to its a value, back to 0, opposite at a, and back to 0. So if my a value was positive, I'd move up. If my a value is negative, I'd go down. That's it. And then I would just oscillate through. Sine always starts at 0, goes to a, opposite it, and then goes back to 0, and so on. Now, when I look at cosine then, if I go back to my unit circle, at 0, what's your x-coordinate at the ordered pair of 0? It's 1. So cosine, therefore, starts at 1, and then at 90 degrees it's 0. At pi it's negative 1. Back up, and it starts where it began. Now, cosine graph. A cosine graph is a sine graph shifted pi over 2. Okay? A cosine graph is just a sine graph shifted pi over 2. I see what you're saying about it looking like a parabola, but remember, those tails are going to continually move back and forth. All right. So here's a nice little gimmick thing to remember. Sine. Starts at 0, goes to a. Cosine starts at 0. Starts at a. Goes to 0. And that doesn't matter whatever a value is. A is 7. It would start at 7, go to 0, negative 7, 0 for cosine. If your a value for a sine function was negative 13, it would start at negative 13, go up to 0, go up to positive 13, back to 0, and down. Okay? It just tells you where to start and where to roll through. Now, I will tell you one thing. The textbook does a way overcomplicated way of writing this out. Go figure. The textbook writes it out in terms of, you know how we did those breakpoints of 0, pi over 2, pi, 3 pi over 2, 2 pi? What the textbook does, it takes it at 0, quarter of the period, half the period, 3/4 period, whole period. That's a pain in the butt. Because what happens when you get weird period values, you don't want to be doing all those fractions in your head. So even though you still are doing it the way I write it, it's less cumbersome. Okay? Miss Hoppenborn.
I don't understand what does period mean?
Period just means the time it takes to make one full oscillation.
Okay, so.
Yep. Before it repeats itself. So
So it's almost always going to be 2 pi?
the generic starting point will always be for the unit circle, sine, cosine, your period is always 2 pi. Because sine will start at 0, move itself up and around, and just keep going like this. And then it just would do this all the way through. So you have 1 period, 2 period, 3 period.
Will we have to draw them depending on how many periods there are?
No. What I normally do is I always ask for 1 cycle. Graph 1 cycle. In pre-calc, what they do usually is that they will graph one positive and 1 negative cycle, one on either side.
Yeah, except, so when you graph sine though, won't it always be like, it'll be the same thing, just like moved around the graph?
Pretty much. But yet you don't even have to move the graph because all you're going to change are these numbers. The curve's always going to look the same.
Is it, how come it's only the difference like sine
you're using the quadrantals starting at, for sine we start at 0, it goes up to 1, back to 0, -1, back to 0. As you watch the y values going around the unit circle, that's why you started at 0, next y value is 1, next value is 0, next one's 1, -1, back to 0. That's why it does that. Let me put one in here with actual values and stuff, and you'll probably see where we're going with this. Yes, ma'am? Yep. It's just a generic where A and B are both 1. This is just straight off the unit circle. I'm going to put some in here now that don't have. I'll have your A's and B's now. All right. I know. But first we have to talk about gang signs. Show us this. I know, it's great. Yes, ma'am. I love it. I think it's funny. Not to scale, yeah, thank you. Y equals 1/3 cosine of pi x. And let's graph that. Y equals 1/3 cosine pi of x. And remember all the work that we've done in the past about labeling what your A, B, H's, and K's and all that stuff were? That's where all this comes back into play again. The more you label out, the easier it is to be able to pick apart what pieces go where within the general forms of these things. Okay? So I know that my A value is 1/3. If my A value is 1/3, that means that my amplitude, how far up off of 0 is 1/3? 1/3. So your amplitude is always found by taking the absolute value of your A value. So you get 1/3.
Wait, so the B is
That only-
5?
Yep.
It only changed if it's negative, right?
Correct.
So your
Because remember, your amplitude is always how high up it went from 0. Even if it went down, it's still going to go up over 0.
Okay.
Our B value here is pi.
Is it always going to be 5?
No, it could have been 3 pi. Could have been 6. So in this case, if my B value is pi, that means that I can write out my formula for period. My period is always going to be 2 pi over my B value. In this case, it's 2 pi over pi. 2, yeah. Now, the reason that what happens here is I want you guys to think of these A's and B's as scalars. It's just changing the scales of the period and changing the scale of the amplitude and all that put together, okay? That's all this stuff does. So now, whenever I graph these things, I'm always going to draw the exact same thing. I draw this sideways T-chart, and I always start by putting a 0 here, and whatever my period endpoint is, all the way on the right. In this case, my endpoint is at 2.
Oh, and then you just split it.
Then I split it up, because what's half of 2? What's half of 1? Now, this case is really easy, because I wanted to make sure you guys saw one, again, that was simple to how the fractions work. 0, 1/2, 2 halves, 3 halves, 4 halves. So the middle one I'm missing is 3 halves. Yeah, Jade?
The problem always goes B, correct?
Yeah.
Okay.
And if it's not there, what is it going to be? 1. Good. Yep. Because you might have where it might be 7/5 cosine of x. And that just means it's 1. Yeah.
Okay.
Okay. Yeah. So now, what's my A value? My A value is 1/3, so it's going to go up to 1/3, and it's going to go down to -1/3. Cosine graphs, do they start at 0 or do they start at A? A, they start at 1/3. In this case, my A value is positive, so I start at positive 1/3, and I just oscillate.
So it's like, for now at least, it's going to be the same thing each time?
Yep. And what changes tomorrow when we shift them, we start with this as our parent function,
Okay.
and then we add and subtract fractions to them.
And then it's going to be the H and K.
Yep. literally been doing this my whole life, but thank you for thinking that I have been. And it's okay. It's okay. All right? It's okay. Might as well get you with one right off the bat, then you know that you're all going to hate the fraction. So, might as well rip the Band-Aid off, right?
Sure.
You're welcome. Go figure, they won't yell out. Seriously.
There's only 2 of them.
All right. What's your A value? -4. Therefore, what's your amplitude? If your A value is -4, your amplitude is 4. Our B value is, and our period then will be 2 pi divided by 3/4,
Or 2 pi times 4 over 3.
which is 8 pi over 3. Good. Okay. So far, so good? So now we know enough to start with the sideways t-graph. I'm going to have to go up and down 4. I know I start at 0, and I'm going to end at 8 pi over 3. Well, half of 8 pi over 3 would be 8 pi over 6. That simplifies to being how much? 4/3. Okay. What's half of 4 pi over 3? 4 pi over 6, which is 2 pi over 3. So if this is 2 pi over 3, 4 pi over 3, 6 pi over 3, and then 8 pi over 3. So 6 pi over 3 is how much? 6 pi over 3? 6 pi over 3? 2 pi. See how I'm doing that with the fractions? That's the idea. You want to be able to, you want to just place them out with the fractions like that, because if you can count them in terms of your common denominator, it really is quick to go through. Now, if you want to go the long form and know that it's 1/4, 1/2, 3/4 whole of the period, you can multiply all that out by hand. You're going to get the same result. But I always think that it's a little bit easier to take half of it, and there's going to be your common denominator. 1, 2, 3, and 4, and go through it. Okay? Now, your A value is negative, but where does sign always start? At 0. So I start at 0, and what direction do I go then? Good. Back up.
Where are we going up and down 4?
Yep. There's a kid wearing a Labyrinth t-shirt today. Yeah. David Bowie in his full glory.
I have seen Labyrinth. Yes, I have. Thank you. I don't know.
Jim Henson. You okay, Levon? Hopworth, see where I'm getting at this now with the idea of trying to make these marks? Does that make is it? What do you mean by why do we do it? As far as why it's just one period?
No, I don't understand why the setup. But it just keeps going.
Yeah. The reason why we use this setup, seriously, if you're looking at just your values, you start at 0, 1, 0, negative 1 as you're going around. Think of it in terms of x's and y's. This is my y value, and then this is my x value for my angle. This is my y value, this is my x value for my angle, and so on. That's why that works. We're taking...
Never got why only goes out there.
Oh, no, because of the unit circle. The unit circle will always simplify out to have the radius of 1, no matter what.
Yeah, because I just didn't understand why it's always like that. But then I was like, no, you don't really need to know because it's basically
It's just, why is it always a x root 2 for 45, 90s? Because they're scalars. These are all just scalars, and they simplify out. They're just ratios that simplify out. Okay, they just might have been similar figures that all simplify out to mean that. That's just how it works out. It's the way of the world.
so that's what I just why I was breaking because at first I was like, why are this one and that? I was like, oh well, who cares?
What?
Yeah.
Yeah, you just go back. You'd go backwards to negative 8 pi over 3 and cut it in that way. I know in pre-calc what we would do a lot of times when we graph things, we would ask for positive and negative period. Here, I don't care. We're just going to do one period. Don't get me wrong. When we graph things with shift, we could wind up shifting to the negative side, but it's just adding and subtracting fractional amounts. Okay. Okay. One more?
Yeah. I heard you liked my test.
It was good. It was very good. Oh, jeez, I don't know why. Because we were going off on a tangent here for a second, and I started writing the word tangent. All right. So we'll do negative 3 cosine of pi over 12x. What's that? Did you want to do it on your own? Yeah, go for it. Try it out. No worries. No rush. You guys are ahead of where I figured you'd wind up at today, so no problem.
Does that mean we're ahead of second period? Or
No,
is
they
there
would-
any figure us
well-
like slower than second
All right.
periods?
No, you guys usually go a little bit quicker. But second hour today, I couldn't get anybody to say a word, so they just kind of sat there and just went. It is weird because it's so stinking quiet in that class.